Okay, hi guys. I'll try to explain reflection here, how it's drawn, but I do not have a protractor with me, so I can't show it accurately, but I hope you will take note and use a protractor yourself if you're trying it out. Okay, for example, they give you a light ray hitting a surface like this, and they ask you to draw the angle that it will be reflected. So this is the light ray that is incoming from any light source. It's called an incident ray. Incident ray is the main first source of light. Incident ray. So you have to find out where exactly is the reflective ray gonna come out. To do that, first thing you must draw is a normal line. A normal line is 90 degrees to your surface. So if your surface is flat like this, you have to take your protractor, the half circle, and put it here. The center of the half circle, you will see a cross. You have to put your cross at this point, and from 0 to 90, you must see where the angle is 0 to 90, and then you mark it and you connect it with a dash line. Okay, I'm gonna put down the phone for a short while. To get a 90-degree line, and this is known as your normal. Okay, so the normal is very important when you're doing reflection and even for refraction later. But first, for reflection, once you draw your normal line, you take your protractor again. Remember the center of the circle, the center of the semicircle that has a point like this will be on this point, and it will be flat on the surface. Flat on the surface. Okay, so you imagine that the protractor is here. Here is your 0 mark. Okay, and you're going to see if this is 0, okay, what is the angle here to here? Okay, say you find that the angle is maybe 40 degrees. If you're not sure how to look at it, I will explain when we come back to school in a revision class. Okay, say this angle is 40 degrees. So because this is between your incident ray and your normal, this is called the angle of incidence. Okay, already here. Angle of incidence. Okay, incidence, I for incidence. This sign is angle in short form. Okay, angle of incidence. Then with the same protractor, you need to measure out here to here also another 40 degrees. Once you measure out the 40 degrees, you can draw a line to connect it. And then you finally got your answer for the reflected ray. This is how you must draw it out if it's given in your exam. Sorry I didn't have the protractor. We'll go straight in class when we get back to school. Okay, and this angle here, if this is the angle of incidence, and this, because it's between your incident ray and your normal, the angle between the reflected ray and the normal will be called angle of reflection. Angle of reflection, angle R. Okay, which is why the law of reflection states that the angle of incidence is equal to the angle of reflection. This is in your slides, I think the third slide for part 2. Okay, now we're going on to refraction. Refraction, as a recap, is the bending of light waves. So for example, there's a light wave coming through air here, and then it hits glass. So the first thing you must know is air less dense or more dense than glass? Less dense meaning less crowded. So you remember that air particles is gas. So they're all very far from each other. Let me focus that. Okay. The particles are far from each other. In glass, it's a solid. Solid meaning all the particles are neatly arranged next to each other. So it's very crowded. Okay, so that's why this is the dense. This is denser. And this is less dense. Okay, since this is more crowded, the light ray will be slowed down. It's like going from a free road to a traffic jam. Okay, and because it slows down, it will bend. Instead of bending faster, which is away, it will bend nearer because it's slower. So first thing you must draw is your normal line again. Since it's hitting this point, okay, my normal line is the 90 degrees to this surface. Okay, this is 90 degrees. And this is my first normal line. Okay, but this normal line will continue down. Okay, this whole thing is my normal line, because if you see this surface, okay, it's just like this, where this is the surface and this is 90 degrees to it, but here the surface is on this side. So this is your surface and this is your normal. Okay, now because it's going slower, remember that instead of going straight like it would do if there was nothing to block it, it's going to go slower, and slower means nearer to this normal. So where it would normally travel like this, it's going to bend nearer to the normal. Okay, I'll try to draw it out. Something like that. It comes nearer to the normal, bends nearer. Okay, there's no specific angle, but as long as you can see that it's from this point, it's going on straight to the next limit. Because here, once again, it will go out into air. So air, again, remember, it is less crowded, less dense. And because it's less crowded, it can go faster. So how fast will it go? Okay, again, you must draw your normal line. A second normal line, which is also 90 degrees. Okay, because this is your surface border, this is the 90 degrees normal. Now this ray, if it carried on in glass, it will continue going like this, correct? Like that, all the way. But because it's going back into air where it's faster, instead of carrying on in this angle, it will go away from the normal. So it will go faster from the normal, out again. Okay, this is refraction of light. So remember again, from air, instead of carrying on straight, because it's blocked by glass, it will go slower. So it will go inside, nearer to this normal line, comes nearer. Then it travel here. Instead of going on straight, because now it's back into air, it goes faster. Faster means away from the normal. So go further away. And this is the refraction of light. Okay, that's it.